Welcome to yet another video on Isoradi Cloud. In this video, let's talk about how server and client software over the network communicate with each other securely with the HTTPS protocol. So what I have here is a bunch of certificates signed by the root CA certificate, and one set of certificates are given to the server. The other set of certificates, the client certificate, is given to the client, and the server will launch itself with a server certificate, will provide the encryption capabilities. The client will use the client certificate to communicate to the server to authenticate itself with the server. So let's see how those things are done. So what we have in our environment is Python 3 installed, and we are going to create a Python virtual environment and do everything under that for the server side. We are going to install what is called GUnicorn and Flask modules of Python. The Flask will provide the web server capabilities, and GUnicorn will be a wrapper around the Flask environment, and it is GUnicorn that will offer the HTTPS protocol support. And we are going to install Golang and OpenSSL in this environment. So we're going to do everything in one system, but you need not have to do that. You can split this into two entirely different computers connected over the internet or connected over the network. So let's create a root certificate. So the OpenSSL genRSA command can be used to create a root certificate private key. And then we are going to create a self-signed root certificate using the OpenSSL command. So at this point, we have a self-signed root certificate, and this will be the certificate authority for the rest of this video. And then we're going to generate a server certificate. So first of all, we will generate a server certificate private key, and then we will create what is called a server certificate request. And then we will sign this server certificate with a CA certificate. As you can see, the CA certificate and the CA key are also passed as parameters. The server CSR is one of the inputs generated from the previous step. And then we're going to repeat the same thing. We are going to create a client certificate private key and generate the client certificate request, and finally sign the client certificate with a CA, the root CA certificate. The client CSR is the input to this process generated by the previous step. So we have a bunch of certificates and keys, and we're going to use them in the Python and Golang applications, as I mentioned earlier. So here is a very tiny Python server. After creating the Python virtual environment, you write this tiniest of all, tiny Flask application, web application. The purpose of this application is to respond back to the incoming request with / as the endpoint, and it will simply return hello from Flask string. Nothing fancy. And we're going to launch this Python application with GUnicorn. So here is where the things go very interesting. So the Flask server app, that is what we saw in the previous slide. And the GUnicorn will bind this application to the network on the local host with the port 4433. And we will pass in the server side key and certificate. And we also will require any incoming client connection to be authenticated or authenticatable through the client certificate. So the certrex number 2 parameter will ensure that this will be a highly secure web application. It will not honor any encryption only request. it has to be, the client has to be talking to this Flask server through a client certificate. And of course, we also pass in the CA certificates to validate the incoming request. So at this point, the Python web server is up and running and waiting for any incoming requests. And here is a Golang code. Even though it looks a bit complex, it is not. On the right side, you can see the main, and it is opening the CA certificate, the client certificate, and client key in it. And then it creates what is called a client config, and I have modularized it into a separate function on the left side, and it basically creates the TLS config. So it reads the CA certificate first, and then finally it loads the client certificates. And if you look at the last section at the bottom of the left hand side, the TLS config is created, the certificates, the client certificates, and the root CA is also mentioned over there. So basically this TLS config contains the client certificates and also the CA certificate. And then HTTP client is launched with the TLS config that was prepared in the previous step. And then it makes a call to the port number 4433 on the local host. But you don't have to do it on your local system. You can split these applications into two different environments, two different computers connected over the network. In that case, the local host need to be replaced with appropriate IP address. So the client will make a call, and then it will read the incoming data, and it will simply print it on the output. So now let's run this client application while the GUnicorn based Python application is running at the same time. There it is, the hello from Flask string is returned from the Flask Python application, or I should say web application. So this is it. So this is how you can implement not only encryption but also authentication between two software entities. One is called the server, the other one is called client. So the communication between the client and the server will be encrypted, and at the same time the authentication of the authenticity of the client will be ensured by the server. The server will not talk to any anonymous HTTPS client. It has to be carrying the client certificate that is connected to the server certificate, with both of them are connected to the CA certificate. So I hope you enjoyed this video and understood how the confidentiality and the authentication are implemented. This is very simple. This is not the production level code at all. There is a lot more to this, but this is the fundamental. Thanks so much for watching, and see you in another video. Bye for now.